So let's jump into our examples of adding and subtracting rational expressions. So the first one we're looking at is x minus 2 over 3x squared plus 4 over x cubed. These are going to be harder to tell what the common denominator is, but we have to look at just the factors. So here we have a factor of a 3, and then we have x squared. On the right, we just have x cubed. So what's missing from the left fraction, or what do we have in the left fraction that's missing over here? Just the 3. So we need a 3 in this denominator. So we would multiply a 3 into the top and the bottom. Now from the right, we have x cubed. On the left side, we only have x squared. So we need that x squared to match the x cubed, which means we need to multiply in an x on top and bottom. And when we multiply into the top and the bottom, we're going to have to be careful when it comes to distributing. So when we multiply that in on top, we're going to have x squared minus 2x over 3x cubed. And on the right, we would have 12 over 3x cubed. So now our denominators match, and we can just add across the top. If we add across the top, we don't have any like terms, so we would have x squared minus 2x plus 12 over 3x cubed. And one last thing that we should try to do is see if the top factors, that doesn't look like it does, but we would want to factor just in case anything in the top would reduce with anything on the bottom, just like we would look to reduce after adding a fraction, right? If we add two fractions and we end up with 8 over 10, we would want to reduce that. So we would factor the top and see if it cancels out with any factors on the bottom. So let's look at our next example, 1 over 3x squared plus x over 9x squared minus 12x. The first step that we're going to take every time is factor the denominators. So this first denominator, that's already factored. Okay, nothing to worry about there. But in 9x squared minus 12x, what can we take out of there? Well, in each term, we have a 3 that we could pull out and an x. So if we pull out 3x, we would be left with 3x minus 4, right? So now we compare what we're missing. We have a 3 in both of them. We have an x squared here, but only a factor of an x here. So we need to multiply an x into the fraction on the right. And then over here we have this 3x minus 4. We do not have a 3x minus 4 on the left, so we need to multiply in a 3x minus 4. So now we're good to multiply in our numerators. So 3x minus 4 times 1, that's easy. That's just 3x minus 4. And then this is going to be over 3x squared times 3x minus 4 plus, multiply the numerator over there, x times x, so plus an x squared over 3x squared times 3x minus 4. Okay. The x here multiplies with the x there to make x squared. So our denominators match. We can add across the top, and we would have x squared plus 3x minus 4, rearranging the top just a little bit, over 3x squared times 3x minus 4. It's 3x squared, 3x minus 4. And again, we would just want to check quick on the top and factor that. So the top there factors into x plus 4, x minus 1. And just to check and see if either of those would cancel with something on the bottom. So neither of these match anything in the denominator, so we can't reduce that. So this would be our simplified form for that addition. So I hope that you're catching on by now. So maybe we can move through a little faster. Factor the denominators. So x squared minus x minus 12 factors into x minus 4, x plus 3 12x minus 48, we can pull out a 12, and we're left with x minus 4. So in the fraction on the left, we're missing the 12, so we need to multiply a 12 into our numerator and denominator. And on the right, we're missing the x plus 3, so we'll multiply x plus 3 into our numerator and denominator over there. So that would give us 12x over 12 times x minus 4 times x plus 3 minus 5x plus 15 over 12 times x minus 4 times x plus 3. Our denominators match, so we're good to do the subtraction, and we just need to make sure that we're careful here. Since we have subtraction with this fraction, we have to do minus 5x and minus that positive 15. Don't forget to distribute that negative when we subtract. So we do that subtraction. 12x minus 5x is going to give us 7x minus 15 over 12 times x minus 4 times x plus 3. There's nothing in the numerator that we can factor. That's as simplified as it can be, so we're good with our answer there. So last example, 5 over x squared minus 1. Factor that x squared minus 1. That's x minus 1, x plus 1. Again, hopefully you're getting used to factoring. We'll still be doing that for a while. And then on the right, we can factor out an x. So x times x minus 1. So on the left, we're missing the factor of an x, so we'll multiply in an x on top and bottom. On the right, we're missing the x plus 1, so we'll multiply top and bottom by an x plus 1. So then our numerator on the left would be 5x over x times x minus 1 times x plus 1 minus 3x plus 3, make sure you distribute, x times x minus 1, x plus 1 on the bottom. Numerators match. So again, just make sure that we distribute that minus. So 5x minus 3x is going to be 2x minus 3 over x, x minus 1, x plus 1. That numerator does not factor. So again, that's our simplified form there.